So when we take a look at our basic trig, our right triangle trig, when we get going with these, a couple of things to keep track of. And one of them is we have these things called trigonometric ratios. Now, you've seen these before. You've seen before, for instance, with sine. Sine is going to be my opposite side over my hypotenuse, and we'll talk about what that actually means to us here in just a minute. Yes, you should have seen this before in geometry. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, depending on the angle that I'm given, that would vary on which side is which, except for my hypotenuse. So like for instance here, since we'd be looking at these from the angle R's point of view, I kind of like to mark my angle that I'd be working with. And then here's how I find my sides. Since we're dealing with right triangles, the side opposite my right angle is always my hypotenuse. It's always the longest side of any right triangle that I'm dealing with. So then I've got opposite and adjacent. How do I tell the difference? Easiest way, here's my angle. If I go and I just start working until I get to the side that's opposite the angle, that's going to be my opposite side, which leaves adjacent for the end. And I'm a fan of actually labeling them whenever you're doing these, just so you don't get those mixed up. Now, when we're actually trying to figure these out, though, okay, and you've probably seen this before too, but again, as I'm doing them, if you're trying to figure out a way to remember the different, it just kind of lets you say, oh yeah, sine is opposite in hypotenuse, cosine is adjacent in hypotenuse, tangent is opposite and adjacent. And it kind of reminds me of the order that they go in too, because that makes a difference. So when I'm doing that, typically we're going to just put these into fractions and leave them. Occasionally you may be asked to do something as a decimal, but more times than not you won't. So for instance, here we're trying to find sine, cosine, and tangent, but of angle A. So I'm going to mark that. Again, I'm a fan of labeling my sides. So I go over here, and maybe I'll even just use a letter. So it'll be like hypotenuse. There's my angle. If I just go straight ahead from it, that'll be my opposite. And the one that's left is going to be my adjacent. And then I just kind of use my fractions or my ratios. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Put the fractions. And I know it says and as a decimal, but again, 9 times out of 10, you're just going to leave it as the fraction anyway. And so we'll just stick to that, even though we will be dealing with some decimal stuff here in a little bit. So it's not too bad of a deal. So you're like, okay, this might not be too bad. We'll see. We're going to take a look at a couple of these, though, where you might get a twist or two involved. Okay, we're going to look at number 1 and number 3 down below. So it says, find sine of j, cosine of j, tangent of j, sine of L, cosine of L, and tangent of L. Whew. One at a time here. So we'll start, since j is mentioned first, we'll start with j. Now here's the part that gets a little interesting. Yeah, depending on the angle is going to depend on what my sides are. So I'm going to kind of do this a little off to the side. So I'm like, okay, there's my hypotenuse. It's my longest side. Bless you. And then I've got opposite and adjacent for now. Yes, but you're ahead. This is good. So when I go to find the sine of j, I'm like, okay, it's opposite over hypotenuse. But like Rena just mentioned, if you can reduce the fraction, you should. These are both divisible by 4, or you could do math enter and get it to its most simplest form. Especially when we start solving stuff, the smaller the numbers we can get, the easier it's going to be. cosine adjacent over hypotenuse. Four over 5. And then my tangent is opposite over adjacent, and those are both divisible by 4. So that gets me set up for angle J with my 3 trig ratios. So then I switch it up. And I'm going to switch it up with some colors here so it's a little more easy to see. Because then it asks me to do the same thing with angle L. So, especially if you don't have colors, maybe you can use, 2 lines instead of 1 to remind yourself. Here's what changes, though. Hypotenuse will still be hypotenuse. That's not going to change. What changes is the opposite and adjacent, because now I'm here, and this becomes my opposite side. This becomes my adjacent side. Okay, so I have to pay close attention to what angle I'm working with. Because what's going to happen is, now I go opposite over hypotenuse. And it basically ends up being the same value that my cosine was on my other angle. When I do cosine adjacent over hypotenuse, you're like, that's kind of weird. So like sine and cosine just kind of switch. They kind of flip. It's true. Sure, go right ahead. And then my tangent, opposite over adjacent. And I get my fractions. So again, once you get the hang of what the ratios are and the sides you use, they're really not too bad to deal with. Now, the one twist that can get thrown in, I'll be honest about it, that's why we're going to do number 3. What happens if I do something crazy? Like put a radical in there. We're going to have to do a little dealings with this because we're going to keep these as fractions. We're not going to go to decimals. But luckily, at least this time, we're only going to do J, because I really don't want to get this mixed up here. Okay, so we're only going to do J on 3. So let's see what we got working here. Here's my hypotenuse, in my side opposite my right angle. My opposite, which leaves this guy to be my adjacent. And I'm still just going to use the regular trig functions. Now here's where life changes a little. When I go to find the sine, I'm like, okay, so opposite over hypotenuse. Here's my issue. Mathematically speaking, it's incorrect to have a radical in the denominator of your final answer. It's not in its simplified form. So there's a couple of things we can do to fix that. My first thing I can do is I notice the 36 over 24, and I go, hey, I think I can reduce that right away, and that may help some of my issue. Okay, so that's 3 over 2. So I'm like, okay, so 3 over 2, square root of 3. Notice I'm not dividing the radical. I just did the numbers outside the radical. Those are not interchangeable. I can't take a 3 out of everything. But I still have an issue because I still have a radical down here. So here's how I fix that. And we've done this earlier. It's called rationalizing the denominator. And to do that, we're going to multiply the numerator and denominator by whatever that radical is. So here's how that's going to help me. Up in the numerator, I've got 3 square root of 3. Down here, though, let's think about this for a second. Square root of 3 times the square root of 3 would be the square root of 9. 3 times 3 is 9. But what's the square root of 9 equal? 3. So this is really 2 times 3, which is 6. Now some of you may be looking at that going, wait. What crazy mathematical thing did you just try and pull there? Okay. So let's come back to this for just a second. Let me try to not do it all in one step like I did there. Let's do it this way. When I'm multiplying things that are under the radical, I can multiply together. 3 times 3 is 9. So here, the square root of 9 is 3. So I did. Okay, square root of 9 is 3. No radical anymore. And so that's where this 3, let me spit it out there, square root of 3 over 6 comes from, is me just multiplying that out. And at this point, I can still do one last little thing. 3 over 6 is able to be simplified to 1/2, or 1 square root of 3 over 6. I can't reduce the 3 over 6. The 3 is in radical jail. The 6 is not. We're not intermixing. Okay? Whatever's outside, I can reduce. And I do that. So that's how I've got to deal with it if I end up with a radical in the denominator. And that only happens sometimes. Okay? There's some ways to avoid that at times that are going to make my life easier. But sometimes we'll just have to deal with it. Okay, cosine adjacent over hypotenuse. Now this time we get a break. Actually, we have 2 breaks. They will. The square root of 3's, since they're identical, just cancel out. That's nice. And 12 over 24 reduces to 1/2. And that's it. So that's kind of nice. And that one's done. And then finally, the tangent is opposite over adjacent. Again, I want to reduce what I can before I worry about rationalizing. 36 divided by 12 is 3. Be cautious. 36 is bigger, so my 3 goes up in the numerator. But now, similar to what we had to do with sine. Oh, I'm sorry, go ahead.
The first one, how did you get from 3 over 6 to 1 over 6?
Because I'm a crazy man. Thank you for the heads up. See, everybody wonders these things, but nobody ever talks. So for those of you that have been sitting back now, probably seeing for like the last 5 minutes, wait a minute, how does 3 over 6 become 1 over 6? That makes no sense, and you're correct. Because that should be 1/2. Thank you very much for helping me get that situated. See, it goes to show that when sometimes you get rolling along and you're not careful, things can happen. So they even happened to me. So even a better lesson to make sure that we're doing this right. So now, similar back to our sine of j. I can use that square root of 3 to rationalize. So I've got 3 square root of 3. And again, the square root of 3 times the square root of 3, as we saw before, is the square root of 9, or just 3. And check out what happens this time. Yeah, this time I look and I'm like, hey, the 3's that are outside the radicals are the same. Can I cancel those? I sure can. It's just the square root of 3. Nicely done, nicely done. Okay, what's that? Do we have to do 2? No. Okay. Sounds like my hearing's going bad too with everything else. All right. Sure. So then as we flip, we're actually going to start using our values to start doing some calculating. Now here is one thing I'm going to write. We're going to take a look at this in a minute. Okay. Especially as we start to come up with here, when I'm working with you guys and I'm working with my other classes, we've got to make sure that your calculator is in degree mode. because there's two modes in your calculator, degree and radian. We'll get to using some things with radian a little later down the road, but there'll be some times that my honors group will be in radian and you guys will be in degree, or vice versa, and you've got to watch it because the other group's going to, of course, do it the way they think they need to have it done. So here's how I do this. When I first get my calculator turned on, if you hit mode up at the top there by the second button, you'll see when you get down here, there's radian and there's degree. So you'll see my calculator actually defaults in radian. That's bad for me because I won't get right answers if it's there. So I want to make sure it's in degree. And to be honest, they all should be in degree right now because everybody's using degree. So now that I got that set, I can get this out of the way for a minute. And what we're going to do is whatever angle they give us is what we're going to base everything off of. And I'm going to label my sides. So again, opposite of my right angle is my hypotenuse. Opposite of the angle I'm working with is my opposite, which leaves me adjacent for my other side. So, what am I looking for? Well, let's see. Use a calculator to find the length of the missing side. Okay, so if this is my side, I look and I go, well, what numbers do I have? I have adjacent and I have opposite. Which trig function would that be using those two sides? I thought I heard it. Tangent. Okay, because tangent is opposite over adjacent. So, I'm going to go ahead and I'm going to make a proportion of sorts out of this. So I'm going to have the tangent of 64 degrees equals opposite over adjacent. Now, I've got some options here even. Since I'm trying to solve for x, I could turn this into a proportion and just cross multiply. That would work. Because if I went that route, x times 1 would be x. 11 times the tangent of 64. And the calculator is going to do that part for me. I just have to get the initial setup done. So let me get out of my mode here. 11 tangent of 64. And we'll get decimally stuff. And it says round to the nearest tenth. So 22.6 in this case. But there is kind of a little bit of a shortcut to this. Now, I can do the proportion and solve every time. It works. Again, sometimes we've mentioned it before. If you're a creature of habit and you just want to do the same thing, that's fine. But here's the little hint that you can do. If the x is on top, like it is in this one, we're just going to multiply by the trig function. In other words, if x is on top, it's going to be 11 times that, or the side times the angle. If we get into a situation, and we will here momentarily, where x is on the bottom, so let's say those had been flipped around, then we're going to divide by the trig function. So instead of doing 11 times the tangent of 64, I do 11 divided by the tangent of 64. But again, I'll show you what that would look like here in a minute so you can actually see why that works that way. So, when we go looking for some sides, again, just quickly going to label my sides. So there's my hypotenuse. There's my opposite, which means that's going to be my adjacent. I look to see which sides I have. This time, what do we got? What do we got? What do we got? Well, let's see. Looks like I'm working with opposite and adjacent. So this time, we're still going to be in tangent because we've got opposite and adjacent. So tangent of 36 is opposite over adjacent. It's real similar to the one that we just did up in the example. Since x is on top, we're going to multiply these together. Oops, I forgot my 7 almost that time. Oof. Excuse me. Swing this guy over here. So here, since we're going to the nearest tenth, that'd be 5.1. So as I work through these, keep labeling my sides here. So I look, this time I got opposite and I've got hypotenuse. Which trig function is that going to be? Look back to the front if you need to. Sine. So the sine of 63 equals opposite over hypotenuse. Now here's the situation we're talking about right here. If x is on the bottom, we're going to divide this by the trig function, which means it's going to be 12 divided by sine of 63. Because if I did it as a proportion, that's what it would end up looking like at the end. So I'm going to tuck this over here. So it looks like x is about 13.5. And basically that's what I'm doing on all of these. Quick label of my sides. Look at which sides I have to figure out the trig function. I've got adjacent and hypotenuse, which is cosine. So adjacent over hypotenuse. And again, I just look to see where my x is. X is on top. I'm going to multiply. So you see how this can really start to go fast once you've got the hang of it. Okay, one more. And then we'll go ahead and give this a go here. Get that guy out of the way. We'll come down here. Still can fit, good. And again, just label your sides right away. Take a look at where you have values, adjacent and hypotenuse, which would be cosine. Adjacent over hypotenuse. X is on top, which means we're going to multiply. And I let the calculator do the work from here. And here's one of those stories from back in my day type thing. Back when I was dealing with this first when I was in high school, they didn't have as much of the graphing calculators. They were just coming out. They would give us a chart that listed off all the sine and cosine values from like 0 to 90, and we'd have to find it on the chart and then multiply it by hand. So this is much slicker way of doing it.
My dad says when you did use sliders.
Slide rules. I never got to deal with slide rules. I was past then. Well, no, actually quite a bit past then. But yeah, it can be, that was kind of a challenge back then. So kind of interesting.
Well, I got curious with my dad, like, he's like Mr. Math, so I was like, how did you do this when you were a kid? Well, we couldn't advance to this because we didn't have the technology.
That's right. It's true. This is a much harder thing to deal with before. So, okay, angle measures, last thing, because sometimes we might be given sides and we're supposed to find an angle. So here, find the measure of angle T, okay? So I still do my labeling. So here's my hypotenuse, here's my opposite and adjacent. I have opposite and hypotenuse, which is sine. Now, here's where things are a little different when I'm looking for an angle. And I'll explain what I'm doing with the little -1 that you see there here in just a minute. When I'm looking for an angle, I can't just press 29/34 into the calculator. Because if I went and I did that and I just said, okay, I'm just going to do sine 29 divided by 34. Right. That doesn't make any sense as an angle 0.01. So, correct. We're going to have to do second sine and then plug in my fraction. Okay? So second sine 29/34. Then it'll give me my angle. And again, we're going to go to the nearest tenth right now. So that get me to 58.5. So that's really the only thing else that we've got to do. And hopefully, if you didn't remember the second, you'd look at the answer and go, that's kind of dumb. What's going on here? Oh, yeah. I got to do it that way. And kind of work it from there. So let's do a few of these, and then we should be in pretty good shape here. So I'm going to go to number 2. We're finding the measure of angle T. Again, I notice the two sides where the numbers are opposite and hypotenuse, which would be sine. So I just go to my calculator. Do second sine. See that little -1 just reminds me I need to see that on the screen. So T is going to be about 22.9 degrees. But again, the concept's really not that bad. Again, it just takes a little bit of caution. Hypotenuse, opposite, adjacent. I got adjacent, I got hypotenuse, which is cosine, adjacent over hypotenuse. And there's kind of a cool built-in error thing that goes along with this. I'll explain that with this one too. I go ahead, I type this in, hit enter. This time it's going to go straight to this. Now let's say sometime you forget that it's adjacent over hypotenuse and you type it in backwards. You type it in and you're like, okay, I'm going to do second cosine. I got 87 divided by 34. Boom. Okay, anytime you try to do a sine or a cosine and it's greater than 1, which 87/34 would be, you're going to get an error message because you can't do that. So it's kind of like built-in protection about doing something crazy. It's kind of nice. Okay, one last one, and so you don't think I'm avoiding the bad ones. Let's go to number 5. Oh yeah, I'm not going to avoid the bad ones. We actually aren't going to mind those when we're doing these. All right, so here's T. So here's my hypotenuse, here's my opposite, here's my adjacent. All right, adjacent and hypotenuse, cosine. So adjacent over hypotenuse. Now, even if I had the radical in the denominator for this, I don't care, because I'm not doing it in a fraction form, I'm doing it in the calculator. So, do second cosine. Okay. 10 square root, again, is second and x squared. So 10 square root of 3, close your parenthesis, divided by 67. So you'll notice here, that can be my really only dilemma. I'm taking this whole thing, but I got to make sure when I close the parenthesis on my square root to know that it's kind of ending things there. And again, rounding gets me back to 75. So your task is to deal with the worksheet that goes along with it. Wake up, people! Wake up! Okay. So that's what we're going to be doing today. And then tomorrow, there will be a video that starts going into how we can set up the triangles and actually use our trig functions to do some story problems. So we'll tackle that then.